Welcome. I'll begin by interpreting the problem statement. We have a parachute of diameter 35 centimeters. The mass supported by the parachute is 20 grams. The air temperature is 20 degrees C, and we're going to assume a coefficient of drag of 2.2. The goal is the terminal velocity v0. That's the velocity here, and we're told to use a projected area of pi d squared over 4. Let me connect this to what I already know. When a parachute is released from rest, it will accelerate until it reaches a steady speed v0, which is called the terminal velocity. Because the velocity is constant, I know that the sum of forces acting on the parachute must be 0. So I visualize that the weight force is exactly balanced by the drag force. Next, I start my problem documentation. I describe the problem in one sentence. Then I capture most of the details of the problem with my situation diagram. I assume steady motion, which means that the parachute is falling straight, there's no swinging or erratic motion, and I neglect all mass except for the specified 20 grams. Density of air at the given conditions is 1.2 kilograms per cubic meter, and my goal is the terminal velocity. My idea for reaching my goal is to draw a free body diagram, which I've done here. And I have the drag force balancing the weight. Next, I write out the drag force equation and W equals mg. Then I count knowns, shown by the check marks, and unknowns, shown here. As shown, I have one equation and one unknown. I can now solve for my problem goal. So here is the ideas I just said. I have this laid out. Drag force equals weight. I put in equations, and I can see that I have one equation and one unknown. I've got the problem cracked. Let's go ahead and solve for terminal velocity. First, I rewrote the equation and solved for my goal, terminal velocity, and got this expression. Next, I calculated projected area and got this value. My last step is to calculate the terminal velocity. Here's the calculations, and the value of terminal velocity came out to be 1.24 meters per second. In review, when I think of solving a terminal velocity problem, I think of drawing a free body diagram. And in general, there's three forces I consider: the drag force on the body, the weight of the body, and if the body is in a liquid, the buoyant force acting on the body. I was able to solve this problem with a direct approach. I had one equation, one unknown, just putting numbers in. However, many terminal velocity problems require a computer solution or an iterative solution using the method of successive substitution. These types of solutions tend to occur when the coefficient of drag is not specified as a problem parameter. That concludes this solution. Thank you very much for listening. We'll see you next time.